-2. So another thing you can do with this board is it has here a 555 timer, which is up here on the schematic. And so you can use this timer as an external Watchdog timer. You can program one on your Arduino, but the idea is, for a Watchdog timer, the idea is if this freezes, if it locks up and stops working, even though the power is still on, right, then it would stop working. So if you had some project on here, you had it plugged in and you wanted it set up for a long time to continue working for a long time, and you're worried that if it for some reason froze, then it would stop working from that point. So a Watchdog timer still counts in the background, and if it's not reset, it would cut power to itself. Once it cut power, it would come back on, and then it would reset itself and start from the beginning, right? And so then it would keep working. That's what the Watchdog timer is for. So you can also have one externally using this 555 timer. So there are some capacitors here. This one's 10 microfarad, 100 nanofarad, and there's some large resistors here, mega ohm, so 1 million ohms. I didn't have a 400 kilo ohm resistor, so there's two 200 kilo ohm resistors in series. So those are right in here. Okay, and so by using this, you can latch this gate, right? And so keep the power going. And basically you need to program the Arduino to pulse this. And so let me show you that. So again, back to our setup here. So at the heart of this is the 555 timer. So let's get one of those. Okay, so here's one, and you can probably see the circle there next to pin 1. Let me move this out of the way. So pin 1, 2, 3, 4, kind of like that, okay? And then 5 to 8. So pin 1 is connected to ground. So let's do that. Okay, but it's also connected to this 100 nanofarad capacitor. So here's one, the markings there is 104. So that's connected to the high voltage, the positive voltage. All right, let's put it closer here. Not very neat. The legs are bending on me. Okay, there. All right, so both of these are connected to pin 1. And then pin 2 is connected to this 10 microfarad capacitor. So here is the cathode, okay, the short leg, and that's connected to ground. So pin 2 to ground. Okay, make sure that's in there good. Pin 3, that's connected, well, high, it's connected to the positive voltage. Sorry, that's pin 4. Pin 3 is actually what we're going to use to latch our, so pin 3, sorry, mistake there, is what is going to connect to 100 ohm resistor, which connects to the gate of our N-channel MOSFET. Pin 4 is what's connected high. Okay. Pin 5 is actually also connected to pin 2. So let's use this. Double check our connections. Actually, again, I mixed up here. So actually, no, pin 5, sorry, is connected through a 10 nanofarad capacitor to ground. Okay, so here this is 103 or 10 nanofarad. And this pin 6 is connected to pin 2. Okay, so this blue line here. So I'm going to use that. Okay, just double checking that looks good. Okay. Now, pin 7 has this 1 mega ohm resistor connected to the positive rail. So here this is 1 million ohms connected to the positive. And then there is this 400 kilo ohm to, well, basically to pin 6, between 7 and 6. Right, this blue line here comes up, back up. So just for the sake of making this a little more simpler, this is one capacitor. This is actually about 470 kilo ohms, so higher than the combination of these two, but I'm just going to use this for the sake of this demo. Okay, so between pin 6 and 7. So right next to each other. Okay, and then pin 8 is connected to the positive rail. So now, if we have done all these correctly, now there is another connection here that I have sort of ignored, but this is what we're going to pulse to our 555 timer, and it gets pulsed to pin 2. Yeah, to pin 2. Let's use this red one here. To pin 2. Okay, or you could connect it to pin 6, right? Same thing, because they're connected across this white. Here, let's do that. Okay, they're all connected together. Okay, so let's bring in our Arduino again. Ground. V in. Center pin here, plug in our battery. So now there's no, we're not using the push button, but you can see this powered on because the output of the 555 timer is high. So that pulls this gate high, which then latches the P-channel MOSFET and powers the board. But the way it's set up, this will power off, so it powered off actually, and then powers back on. So it stays on with this setup for something like 13 seconds, then it powers off. Let's wait for it again, okay, and then it comes back on again. So the point of this is, now if you are to send a low pulse to this pin here, before that 13 seconds, then it will actually not shut off. So I'll put it to the low rail here. Okay, and you'll see it's still going. And so in the programming, if this is connected to one of the Arduino pins, you could use that to pulse it low. Okay, the problem is if it stays low, this will never turn off because this will never stop pulling the gate high. Okay, so that's what all this is for. So all this, if you put a high signal at this end, this circuitry will give that low pulse. If you don't do that, then again this will time out, it'll shut power off, and then the Arduino would restart again. Okay. And this is connected to one of the digital pins, if you, instead of pulsing it, were frozen high, this will actually will stop giving that low signal, and then actually it will still time out. So whether your Arduino freezes up with a high state or low state, this 555 timer would eventually shut off. That would turn the power off to the MOSFETs, and then the Arduino would reset itself. So that's what this does. So let me just show you this circuitry here. Let me just power this off here. So let me move these out of the way again. So the first is this 10 kilo ohm resistor to ground. So let's use that. So here's another 10 kilo ohm to ground. Okay, next to it is another 100 nanofarad capacitor. So the 104. Oops. Okay, so that's connected to the resistor, and then this end is connected to another diode. Also this 27 kilo ohm resistor. So here's our diode. Here's the cathode with the stripe connected to the ground rail. Okay, and this capacitor, and then 27 kilo ohms. Here's our resistor, also connected to the ground rail. Okay. And then we need another N-channel MOSFET. So here we go. Here's another one just like this one here. So these two are the same. Again, it's FQP30N06L. So remember, this is gate, drain, and source, but the gate is connected to these components here. So I'm going to turn it around. So now the gate is on this side, and plug those in. So now the gate is connected to one end of that capacitor, one end of this diode, and one end of this resistor, right? It's all connected at one spot. The drain, the center pin, is connected to our pin 6 and 2 again. So that was this red wire. So that's the center pin. Okay. Sorry, that's my multimeter powering off. And then the source pin is connected to ground. So let's put that in there. And so the point of this one, again, was if this point here, as long as we pulse it with, in this case, a high pulse, that will send a low pulse to our 555 timer, and it will not time out. So this goes to the connection between the capacitor and the resistor. So there. Okay, so let's plug this back in. Plug in the battery. So it should power up. And then in 13 seconds, it should power off. Excuse me. Ready for it? There it goes. Okay, and that powers back on. So it'll reset itself. However, if we pulse this circuitry with a high pulse, okay, whether it's from, well, it would be from the Arduino, right? And in the programming, you need to pulse it. Yeah, maybe every 10 seconds is what I usually set it for. Then the power will never shut off. Okay, if it freezes and it stops pulsing, either with a high or a low. So here, let's give it a high. So now in 13 seconds, even though this is a constant high signal, this will cycle through and it will power off. So let's watch for that. There, it powered off, right? And so then the Arduino would reset itself, powering up again, and then hopefully you would get your regular pulses. Okay, and so that's what this Watchdog timer is for. Okay, so you need something to pulse it. Again, maybe every 10 seconds or so. Right, and so that's what this part is for. You could actually pulse this with another component, you know, so this is an AT-Tiny 85, which there's a spot for one there, right? And that could pulse this circuitry, right? Connect this to a different sensor and stop pulsing for some reason or keep pulsing. Okay, so those are some of the basics of this shield. I hope that was helpful, you know, understanding some of the circuitry, how it was hooked up together. All right, thanks.